talk after lunch, right? So my name is Elita Lee, and I'm kind of the group leader of this project called Sustainability Geophysics. And when I came here, the question becomes like, how could we call ourselves sustainability geophysics? It turns out the research we do is really all the geophysical applications around the energy cycle. And my academic career started from working with the oil and gas industry, trying to find the most efficient way to extract energy from the subsurface. So we learned a lot of fundamental understandings of waves of rocks, of the physics that you see this morning. And then specifically, my group and my research design a lot of imaging and inversion algorithms to take what we measure as seismic data, image the subsurface, and image or invert for the properties of the subsurface. So starting from there, I'm still working on this through a lot of collaborations. We moved on to optimize the energy usage in a lot of the infrastructure construction or site investigation, and trying to really use efficient method to use the energy more wisely. And moving forward, we are also doing a lot of monitoring. So a lot of the inversion method or investigation method, in my analogy, is like taking a picture of the subsurface, which is already something very important because we don't see the subsurface using our naked eyes. But moving on to the monitoring regime, it's like taking a video of the subsurface. We're putting the time dimension there, trying to see what has changed over the time, and whether it is for geohazards or for infrastructure, smart city, or for the changes of the subsurface reservoirs. And then we also worked on reclaim and recycle, where projects on land reclamation using waste materials or creating more spaces in cities like Singapore, trying to do land reclamation from the sea. So these are, the time-lapse monitoring and recycle aspect of our research. And finally, of course, we come back to the full circle where we generate all these energy, and using them, we were generating a lot of carbon dioxide as well. So how do we deal with them? We had a whole session this morning talking about CCS. And our research interest in particular is to monitor what is going on in the subsurface after we inject CO2 into them. Okay, so just in the past year, I'm going to give you a bit of highlight what we have been doing. For the surface wave inversion, Yanlong is online. This is his really good work. We try to design inversion algorithms instead of picking these lines that is very ambiguous in a very complex data. We can try to fit a whole dispersion image. And that it's kind of a step in between of these very extremely simplified analytical solution and very complex full forming inversion methods that some people may be familiar with. And in addition, Nan is also in the audience there. So we continue down the road of using machine learning to look at the data that we acquire in the subsurface. So these are the borehole images that maybe Wayne would acquire or still working on as well. So non-designed or utilized machine learning models to do image classification or lithological classification using these very complex borehole images. So when we look at the infrastructure monitoring side, we've been blessed with new data acquisition technology called distributed acoustic sensing. And this is an example where we instrumented a building, a corridor, and we were able to, the student in Singapore tracked the indoor occupant. And what you see here is a person going up and down the corridor, up and down, and up and down. So there are many applications of this kind of sensing for built environment. And we also did projects in the tunnel where we continuously monitor the seismic vibration coming out of the tunnel boring machine. And with those information, we'll be able to see what's ahead of that tunnel head. That's the dot there. Is there any geological risk ahead of that cutter head? So as the cutter head move forward, we build a more complete profile of the geological conditions ahead of the cutter phase. And I'm showing this picture or video again. We are doing wind farm monitoring. One wind turbine fell down, and that was the seismic data that we recorded about 500 meters away from that wind turbine. So this, we didn't predict that the turbine would fall, but the data sets will give us a hold on, what could be the precursor of that kind of catastrophic event. Okay, I have to speed up. In terms of carbon sequestration and reclaim recycle, I think what you've learned this morning is that we realized CCS is not just a technical and engineering problem. It's a community problem. So we brought in political scientists, we brought in economists into the CCS project. Hopefully we will build the system ground up for future deployment. And this is the study we've done. You've seen the study from Elita that is based upon this storage potential estimation project we've done in Southeast Asia. And we're also thinking about the long-term nature of a CCS project. So we will have to monitor the subsurface for 20 up to 50, 100 years long. So how do we really capture that long project cycle into the expertise, keep them there? What we have designed is a machine learning model where the expertise is learned using the neural net and kept there for many, many years to come. So with that, I think I come back to the cycle, and I hope I'm not too over my time. Then I will hand on. I probably won't take questions at this moment, but you will hear a lot more topics along this cycle in this afternoon's program. So we will start by Omong, who will